Good evening. So today we are going to discuss about house price prediction using machine learning. So I will be using Jupyter and this is my Jupyter notebook. So let's start the code. First thing is importing the libraries. So our first library which we are going to use is pandas. Import pandas as PD. Okay, so PD is a short name for the pandas. Now let's read the CSV file. So we will be using this method read CSV. So here we have to give the file name, which is a CSV file. So coming back to our home page, we can see that the CSV file name is housing.csv. Housing.csv. So now we have to store this data in a variable that is df. So now our data is converted into data frames. So data frames is just like a rows and columns, where columns is the features. Okay. So let's display the data frame. Now we can use the methods just like head. Head is a method of the pandas which we can use directly. So head will display the first five records. Similarly, tail will display the last five records. Okay. So we can see that now if we want to print the rows and columns, we can use the shape. Shape is the attribute. So we have to do df dot shape. So we can see that we have 545 rows and 13 columns or features, in which one feature is the dependent feature and others are the independent feature. So price depends upon all these features like area, bedroom, bathroom, etc. Now let's print the columns. So again we have a columns attribute. We can use it with the df to print the columns. Now we can see the information. What are data types of the columns? How many null values, not null values? All things can be seen here. Okay, so 545 non-null values are present. Now again, if you want to check for the null values, so df dot is null dot sum. So that is a method. It is going to sum the it will print the how many null values are present. So it will do the sum. But here there is no null value, so everything is zero. Okay, so let's start now. First of all, we need to convert this. Uh, you can see in the main road we have yes or no. So these are the categorical feature. Machines can only understand 0 or 1. So we need to convert this into 0 or 1 label encoder encoding we have to use. Okay, so we have to apply the label encoder on main road, guest rooms, basement, hot water heating, and air conditioning, and all this. Okay, so um, so we will be using label encoder, and for that we have to import the libraries. Let's import. So from sklearn dot pre-processing import label encoder. Okay, so now label encoder will be imported. We can use it. First we need to create the object of label encoder. So we can do like this, le equal to label encoder. So now we have a method which we can use of label encoder, that is fit transform. Okay, so it will convert into 0 and 1, and similarly we are training, and we are converting the yes or no to 1 and 0, and later part we can do inverse also to get back to the original data. We can do that. So first we are going to train what is the meaning of 0, what is the meaning of 1. We are doing this because machine cannot understand English language. It is a human being only which can understand. Okay, so now let's see. So we just do the label encoding for the main road, because again 0 and 1 we need. Okay, so we will do this, and whatever the result we will take back to the same variable. You can use other variable also, and later you can drop these old variables. It's your choice. Again, next is our guest room. whether their house, whether in a house there is a guest room or not. Uh, if it is, then it is yes, otherwise it is no. So again, we need to convert this into the 1 and 0 form. So we are doing this. Okay. Similarly, we can try for the basements also. Basement. Okay. Same. The result is again stored in the same variable. You just need to remember this. Okay. Uh, Again, df column name, feature name, and this. Okay. And then we can do similar thing for the hot water heating. Okay. So we have to do this again, LA dot fit transform. Okay. So yes, this is over. And next is the air conditioning. We have to do the same thing for this also. Air conditioning. Okay. Uh, yes. So LA dot fit transform. Okay. And do this thing. Okay. And last one is the preferred area. Okay. So let's see what's the mistake in it. Yes, this is a spelling mistake. So you can correct it. Okay. So last one is the uh, what it is pref area. Okay. So doing this thing again. Yes. So le dot fit transform. Okay. Yes. So now finally we have achieved, yes, last one is remaining. This also need to be convert. See, suppose there are multiple classes, then numbering can be like 0, 1, 2 if there are more than two classes. For two classes, we can have one or zero binary numbers, as you remember. So we have to do last fit transform on this also. Okay, so that we can get the exact what we want. Okay. And let's see now. Yes, so all the things are converted. So now we need to divide the data into training and testing. Okay, so what we can do, we can again use some libraries from sklearn, dot. Now we have to use model selection, because in the model selection we have the train test split. Train test split. You need to remember this. Okay. So this is a method by which you can divide the data into training and testing. Okay. So now this is a method. So now we have put the bracket. So now if we enter a shift tab, so you can see that there is a help option with us. So in the documentation, if we go down a little bit, so we get some solution. We can just copy paste this solution. So in which it is written that we are dividing the data set into training and testing, and test size 33% and the training size is 67%. You can change also. Okay. So what we can do is we can copy paste the code and from the example part, and but before doing that we need to have x and y dependent and independent feature. So I will create x. So in the x we will have the dependent features, sorry, independent features. Okay. So drop, so we will drop the price because we need to separate dependent and independent features. Okay. So x is equal to 1. Okay. Similarly for the y also, in the y we want to predict the value of y, that is the price. So y will be the dependent. Okay. So now we can easily execute our the last line. Now, if we see the shape, so we have 365 rows and 12 columns. Okay, and similarly, if we see the training y train dot shape, so that is 360 because there is only one column, so that's why comma nothing is given. Okay, similarly, we can print the shape of this also. Okay, and that is 180. So now how this values is coming, let's see that if we 545 is a total number of rows, if we multiply with 0.33, what value we get? We get 180, approx 180. That is our testing size. And again, if we see into 0.67, we get 365. Okay, so we can match whatever is the training data and whatever is the testing data. We can always change also. Now we are using random forest. So again, from sklearn.ensemble import random forest. Now we have to decide. We are working on uh, contiguous values. It is not the classification, it is a regression. So random forest regressor. Okay, random forest regressor. Okay, just remember this. If you are dealing with classification problem, one or zero, or multiple classes are there, so we will use random forest classifier. And if you are dealing with the contiguous values, because price is contiguous, okay, it can sometimes go up, go down. It is not fixed. There is no interval. We can say that. Okay, that's why. Okay, random forest regressor. Okay, so now we will create the object. So random forest regressor. Now we have developed the model. Now we will train the model on our data set. And so we will use X-train and Y-train. Okay, so X-train, Y-train already we have. So we can just use this because it is a method. It needs some arguments, X-train and Y-train. Okay, so once the training is over, now model is ready to predict. So again, using the same object dot predict. Okay, so now we need to predict the so now, uh, what we can pass. See, model is already trained. So now, if we give the X test, okay. So now it is a testing phase. So it will predict the Y value, but Y. Okay. So now we can print this, and okay, we can see the values are being predicted. Okay, but now the question is, we are dealing with regression problem. So here in the regression, we will see the R2 score. Okay, so remember this, if we are dealing with the classification problem, then accuracy is measured. Accuracy can be from varies, can be from 75, 80%. Ideal should be above 75% accuracy. Well, how model is accurately predicting the correct values. Okay. And in case of regression, we use R2 square. Okay. R2 score, sorry, R2 score. Okay. So again, from sklearn, you just need to remember sklearn.metrics import R2 square. R2 score, sorry, score. R2 score, not the square, sorry. R2 score. Okay. So regression problem, R2 score, classification problem, accuracy. Okay. And in the same metrics, accuracy can also be uh, included, but we don't want, so we are not used. So coming back to our problem, R2 score. So here what we need is Y true and Y predicted. Okay. So Y true means the actual value and Y predict means what model has predicted. So comparing both and finding the R2 score. Okay. So now let's see. So Y true is our this Y predicted value. Okay. And next is Y true and Y predict. Okay. So Y true is our Y test. Sorry, Y test. Yes, Y test. Yes. So 60% is the accuracy. Okay. So we completely agree that this accuracy is not very good, and we can improve also by removing the outliers. We will see in the next lecture how to remove the outliers using the IQR method. Okay, interquartile range, and improving the accuracy is very important because our model will correctly predict that, then only it is useful. Okay, so 60% is not very good, and the rest is errors. We need to reduce the errors, and we need to improve the model's accuracy. Okay, so that is all about the introduction, and I hope you get some idea how to do these things, how to do basic uh, basically analysis of the data using the head method, tail method, and attributes. Okay, so these all things are very important, and it is just a base. And in the coming lectures, we will see more about it. Okay, so thank you very much for watching this video. I hope you gain some knowledge. If you have any question, you can mail me. Okay, thanks a lot. Thank you.